Let's take a look at section 2.5, exercise 14. So here's one that I really can't solve for y. Oops, cotangent y is equal to x minus y. Now I need to take the derivative of the cotangent. I don't know if we figured out what the derivative of the cotangent is or not. I never remember what it is. Instead, what I remember is cotangent is the cosine over sine. So, I would rewrite this as cosine of y over sine of y is equal to x minus y. And I would deal with it this way. Now, okay, let's do the implicit differentiation. All right, so I need to take the derivative of cosine of y over sine y with respect to x, and that's equal to the derivative of x minus y with respect to x. Okay, quotient rule on the left side here, so derivative of the top, that's the minus sine of y, but then times, I'm going to use y prime, times the bottom, sine of y. Okay, then minus the top, cosine of y, times the derivative of the bottom, so that'll be cosine of y, but then times y prime, all divided by the thing on the bottom squared, so sine squared y, and that is equal to 1 minus, and the derivative of y with respect to x is just y prime. So I've got a bunch of y primes, y prime in this term, and this one over here. How do I want to deal with this? Well, sine squared y over sine squared y, that's just 1. So I think I'm going to first write this as minus y prime, and then minus cosine squared y over sine squared y times y prime is equal to 1 minus y prime. Now what's nice about that is when I add y prime to both sides, those y primes disappear. That's pretty awesome. And I get minus cosine squared y, cosine squared y over sine squared y is equal to y, or times y prime is equal to 1. Divide both sides by this nasty looking thing here, which really isn't so nasty. I get y prime is equal to minus sine squared y over cosine squared y. And actually, since sine over cosine is the tangent, I could just write that as minus tangent squared y. It's pretty nifty. So there's the derivative of this cotangent y equals x minus y. I didn't see that one coming, but there we have it, is y prime is minus tangent squared y. So there we go, number 14.